It sounds skeptical, but it's happened downstairs, right? Okay. This one you can read, okay? About 100 years ago, the president of Royal Society in Great Britain, they said anything heavier than air cannot fly. Now say how many flying out from Malaysia to Lanka? Or to anywhere else. They're very heavy, right? In 1943, IBM, the chairman, at that time, how big is a computer? You fill up the whole building, the whole floor of the building, one computer. Right? So this president of IBM said, there is a world market of computer of just 5. We can only sell 5 computers to the whole world. Now instead, do you have more than 5 computers in NMU? It's even more than that. Alright, things always sound skeptical. They are more, okay? But we can keep ourselves skeptical, but we have to look into the details and see what will be the promises, what will be the challenges for us to solve. Can we make this come true? Okay? This is how the civilization of mankind. Okay? Now I'm going to give you the example of the so-called carbon nanotubes here, right? To give you some idea about nanotechnology. Diamond, right? All these materials are based on carbon. This is diamond, right? They are made of carbon atoms. And all these carbon atoms, for example here, they bonded to 1, 2, 3, 4 in the tetrabonded structures. They have 4 good friends. Okay? Every atom has 4 good friends. So it looks the same in every direction, and they're very strong. That's what they call diamond. And they are insulating, transparent, right? And now, if you move down here, the so-called graphite, they also constructed by carbon. But each carbon atom is now connected to 1, 2, 3, only 3 neighborhoods. And they form the hexagonal sheet structures. Every sheet we call graphene sheet. And this is what you have in your pencil lab. When you draw something on the paper, you actually scratch away layers of them, layers of carbons deposited on the paper. Okay? So you can see, by changing the way the carbon atom arrange themselves, bond themselves, they become very different materials. So this is the inspiration of nanotechnology. If I give you 1 million pieces of carbon, what would you construct? You can construct carbon by all the carbon atoms to diamond, or you can make graphite. It's up to you. Okay? So this is how the whole idea is. And in fact, you can take 1 sheet or 1 layer of this graphene sheet, roll them up to form the so-called carbon nanotubes here. Right? That is what we have for the game. Right? Those carrying the plastic sheet, you are actually having 1 piece of graphene sheet. It looks like hexagonal shape, right? Okay? And at the corner of each hexagonal structures here, you have 1 carbon atom. Imagine there is a carbon atom here. Okay? And now, it depends on how you roll it. Okay? You roll it in this direction, left, right, top, down, or any direction here. You will form a layered structure like this. Okay? Become a seamless cylinder called carbon nanotube. Right? What is interesting is that you can fold them as small as 0.4 nanometer. Did I tell you how small is 1 nanometer already? 10 hydrogen atoms. 0.4 nanometer means about the length of 4 hydrogen atoms. Right? So this is how small the tubes can be. Right? Not only that, you can make carbon nanotubes, depends on the way you fold it. They can conduct electrons like wires, metal wires. They become conductor. Or you can use them to replace silicon because they can be semiconductors. Right? Or you can use them for high-tech application because they can behave like superconductor. So just a single sheet of carbon depends on the way you fold them to tubes. They can be metal, they can be semiconductor, they can be superconductor. What is more challenging here is that, or more interesting here is that they can be very strong, right? Stronger than steel, 5 times stronger than steel. I told some of your friends here, carbon, you know the atomic mass, right? It's 5 times lighter than iron. Okay? So which means if you use carbon to make your car, Your car can be 5 times lighter than what you have right now. And not only that, they are 5 times stronger. Okay? And I highlight here the young modulus here, right? They can also bounce back, right? If you bend them, they can bounce back. So this is the game. I think who is having this kind of graphene sheet? Hand up. Oh, it's kind of random. You have to look carefully. I don't think so. One of you having this. One of you having different one. Who is having this? Zigzag structures. Those over here. Is that right? Okay, now this is the game. If you look at this, okay, this is better. This one having some problem. You better change the field emission display. Okay, now look at this. These edges here, the left one. If you see carefully, can you join these edges to the right? Can you join it? Show your friend. And you will find that if you join this, right, it will be seamless. Just like your zip. You zip it, it go perfectly. Okay? If you do that, right, and then you take it out, can you see these zigzag structures? Can you see the zigzag structures? Alright? So if you have this, this is called zigzag carbon nanotubes. Isn't this simple? You have zigzag, you have zigzag tubes. Alright. And now, don't worry, friends over the other side. You are supposed to have this, right? Okay? And now, much simpler. If you fold this zigzag boundary on your left to the zigzag boundary on the right, you are supposed to make the zip seamless, perfect. Can you try? Join the two boundaries left and right together. You get it? It will form seamless tube, right? And if you hold it upside, can you see this red mark like a chair? It looks like, I cannot bring this chair. It looks like a chair when you're looking at it on the sideway, right? Is it okay? Can you see it? So you fold it up like this, you will see the chair, just like the red mark here. Okay? So this chair is armchair. Okay? And we call this armchair nanotube. So if you have the tubes built by this armchair nanotube, they are supposed to be metallic. They will conduct electrons just like wire. They are conductors. For those who have the zigzag tubes earlier, alright, 1/3 of them will be metallic. Only 1/3. 2/3 of them will be semiconductor. Okay? And not only that, if you don't trust me, you can try. We can keep this for you. You can fold the sheet, not left to right, not bottom up. For those who are holding this, okay, if you fold top to bottom, you will form the armchair as well. For those holding the armchair, if you fold it from top to bottom, you form the zigzag. Actually, it's just symmetry at 90 degrees flip over. So if you do that, actually you can fold seamless nanotube in any angle between 0 to 30 degrees. Okay? Believe me. If you don't trust me, if you don't believe, go home and try. Okay? So this is what we have done. Okay? You can fold the tubes to zigzag tubes, looks like this. Or you can fold it upside down, become an armchair tube, right? Looks like armchair on the other direction. Or you fold it in any direction, you form the so-called chiral tube. Right? And this chiral tube will be semiconductor. Okay? So it depends on the way you fold it, you can make the nanotube behave in the way you want. And not only that, it depends on the diameter.